Welcome to today's Explainer. We're going to completely flip how you look at some of the absolute most intimidating beasts on Earth, crocodilians. We're going on this wild journey from the micro, how they behave right now in the wild, all the way to the macro, zooming out to their breathtaking evolutionary history over millions and millions of years. It's a fascinating look through deep time, so let's kick things off with an everyday challenge.
All right, let's just jump right in with a question I know we've all secretly asked ourselves at some point. How on earth do you actually tell an alligator and a crocodile apart? I mean, at a glance, they look almost identical, right? They both have that heavily armored skin, those terrifying jaws, and a family tree that stretches back over 200 million years. But if you look a little closer, nature has actually equipped them with very specific tools for very specific jobs.
So the dead giveaway? It's all about the snout. Alligators have this really broad, rounded, U-shaped snout. That wide base gives their jaws incredible crushing power, which is perfect for cracking open hard, armored prey, think turtles and shellfish. Crocodiles, on the other hand, rock a much sleeker, pointed V-shaped snout. And that narrower shape reduces water resistance, meaning the crocodile can snap its jaws shut at lightning speed to catch fast-moving fish. It is just a brilliant example of form perfectly matching function.
But the differences definitely don't stop there. Because an alligator's upper jaw is wider, it neatly hides its lower teeth when it closes its mouth. But a crocodile, its upper and lower jaws are roughly the same width, so you get this terrifying interlocking toothy grin where the fourth lower tooth literally sticks right up over the top lip. Yikes. Also, while alligators are generally darker and stick to freshwater in places like the southeastern US and China, crocodiles sport a lighter olive tone and actually possess special salt-excreting glands. This neat trick allows them to dominate both freshwater and saltwater habitats globally. Oh, and as for temperament, well, crocodiles are notoriously way more territorial and aggressive.
Section 1. The Modern Apex Predator. Profiling the Nile Crocodile. Now let's zoom in on the Nile crocodile. These guys aren't just brute swimming tanks, they're actually wildly sophisticated hunters. Their faces are covered in tiny little bumps called integumentary sensory organs. And get this, these bumps are actually more sensitive than our own fingertips. They let the crocodile detect the absolute faintest vibrations, chemical changes, or even temperature shifts in the water. Plus, they're highly social creatures. They actively hunt together, sometimes herding fish into the shallows. And when they wait in ambush, they can literally launch out of the water to take down a full-grown African buffalo and then devour up to half of their own body weight in a single feeding. Just incredible.
And to really wrap your head around their immense power, an adult male Nile crocodile can reach a staggering 20 feet in length and weigh in at 2,200 pounds. That is over a ton of pure muscle, armor, and teeth. Absolute behemoths of the waterways.
So you see this heavy armor, you look at their raw power, and knowing their lineage stretches back to the early Jurassic period, you kind of have to wonder, right? Are they just leftover dinosaurs? Did they simply find a comfortable swamp somewhere, hit an evolutionary plateau, and just forget to go extinct?
Well, for decades, scientists actually thought just that. They labeled them as living fossils. There's this heavy jargon-filled term for it, bradytology, which basically suggests the species suffered a deep-time decline in its evolutionary rate. The assumption was that crocodilians used up all their evolutionary energy millions of years ago, eventually stagnated, and just stopped changing altogether.
Section 2. A punctuated evolutionary history. Debunking the stagnation myth.
But recent data completely shatters that myth. When you actually map out the evolutionary rates of crocodile ancestors, sure, you see a slow, stable baseline, but then, completely out of nowhere, you get these massive bursts of intensely high evolutionary rates. We are talking about massive marine forms and galloping, land-dwelling hypercarnivores running around during the Mesozoic era. This proves definitively that their family tree is anything but stagnant.
So, throw out that idea of a slow, lazy crawl. We now know their deep-time history is actually defined by something biologists call punctuated evolution. It's a model characterized by long, quiet periods of absolute stability, which, tricks us into thinking they don't evolve, but those periods are forcefully interrupted by sudden, violent bursts of rapid biological change and adaptation. If you track this speed across different geological eras, you get these long, quiet plateaus, and then, bam, massive, jagged spikes in their evolutionary speed. And what researchers found super compelling is that these spikes occur right around major catastrophic shifts in Earth's history, like mass extinctions and really drastic climate shifts.
And this brings us right to the heart of a massive scientific debate. What actually drives this kind of large-scale evolution? On one side, you have the Red Queen hypothesis, which says evolution is driven by intrinsic biological competition. It's that classic arms race between predators and prey, where you have to keep running just to stay in the same place. On the other side is the wonderfully named court jester hypothesis, arguing that evolution is mostly driven by random extrinsic environmental shocks. Massive volcanoes, asteroids, or shifting climates that suddenly change the rules of the game overnight.
Section 3. Climate, Temperature, and Size. The court jester takes the crown.
So, who wins the debate here? Well, researchers ran the statistical regression analyses, and they confirmed it is all about the heat. Warmer global environmental temperatures directly fueled their rapid evolutionary leaps and allowed them to achieve those unbelievably gigantic body sizes we see in the fossil record. The court jester takes the crown.
Looking at the Cenozoic era, the data is literally undeniable. As the planet got hotter, their evolutionary rates and their body size variance just absolutely skyrocketed. A warming planet essentially opened up their ecospace, allowing these cold-blooded reptiles to rapidly evolve and dominate brand-new ecological niches.
But here's what's absolutely mesmerizing to me. That deep connection to climate, it isn't just ancient history. It persists in modern crocodilians right now. Take the Nile crocodile we talked about earlier. The exact temperature of the sand where the mother buries her eggs literally dictates the biological sex of her babies. If the nest is cool, say under 87 degrees Fahrenheit, the hatchlings will be exclusively female. But if it's a warm nest, hitting between 87 and 93 degrees, out come the males. Their very biology is still completely tethered to the thermometer.
Which leaves us with a pretty wild thought to end on. Knowing that temperature has basically held the remote control to their macroevolution for a staggering 247 million years, and seeing how it still intimately dictates their biology today, as our global climate rapidly changes once again, warming our atmosphere and oceans, what will be the next macroevolutionary leap for these ultimate survivors? Are they going to grow larger? Will they branch out into entirely new forms? One thing is for absolute certain, they are not living fossils. They're just waiting. Thank you for joining me on this explainer. I hope it completely changed how you look at the water's edge.